the last time we finished 2015. So 2015 is done. 2015 is done. Okay, now we're gonna do 2014. Let's see what is 2014. Let's see. 2014. 2014. This is key. 2014 reasons from 51 to all the way 85. So let's start with 51. So using the ruler. Oh, okay. So again ruler. So this is our ruler. So this is from so discover 0 centimeter. So 0 centimeter to 10 centimeter. So using the ruler, determine the scale used in the vector diagram. So we have to find this vector diagram. So put it here like this. Put it here 0, and this is 6. So put it here 0 to 6. So 0 to 6. So 1 centimeter. So 1 centimeter is, so this is 60 centimeter. So 60 centimeter gives us 60 centimeter gives us 60 centimeter. 60 centimeter gives us 60 Newton. What am I talking about? 60 Newton gives us 6 centimeter. 6 centimeter. Then 1 centimeter gives us what? So divide by 6. 10. So 1 centimeter gives us 10 Newton. So 1 centimeter gives us 10 Newton. 10 Newton. I hope you understand that. And let's do the 52. 52. Draw the resultant force. Draw the result force. This is the easiest thing you're going to ever do in the reasons. All you need to do, find the resultant. And now resultant you can find different way. Resultant is x square plus y square. So x square, this is x, 60 square plus this is y, 80 square. And that's how you can find it. So 60 square. Now they ask you to find, draw the resultant, determine the magnitude of resultant force. Magnitude of resultant force. Let's see, 60 square times 60, that gives you 3600 times 80 times 80, that gives you 6400, and that 100 meter. So this is 100 Newton. So this is 100 Newton. 100 Newton. There is other way you can find it, of course. So find 0. So find 0. Where is the 0? So 0. So 0 from 0 to here. So it's just 10. This is 10 Newton. So 10 Newton times 10. So which is 100. Find the angle between north. So north and resultant. So this is north and resultant. So you have to find this angle. So what is this angle? So let's go to this one. So go this one, go to this one, and they are aligned. This line, this black line, and this red line, this black line, and this red line align. Okay. And then this dot and the middle one aligned. So the red line underneath and the black line on the top, they are aligned. Once that happen, you're gonna come here. You're gonna see where is this? You're gonna see. Let me do it this way. This is 0. So 0. So this is 30. This is 37. So this is 37. 37. As you see that this is 0, 10, 20, 30, 37. So this is 37. Once again, I'm going to write plus minus 2. 37 degree plus minus 2 degree. Okay, that takes us to the next one. The next one is 55 and 56. And 55 and 56 ask us to calculate the spring constant. Again, Hooke's law. So a spring constant, once we do the spring constant, we have to write the Hooke's law. F is equal to kx. And we have to find, it says that calculate the spring constant. So spring constant means k is f over x. So let's see what is our f. F is 3 Newton force, so 3 Newton, and x is 60 centimeters. So 60 centimeter, 60 centimeter. Centimeter is not SI unit, so you have to convert it to the meter. So 60 centimeter is 0.6 meter. So 0.6 meter. So now we have to omit this we have to remove this decimal by adding a 0 on the top. over 6 meters. So this 5, so it's 5 Newton meter. So the answer, final answer is 5 Newton meter. Now that takes us to the 57. 57. All right, so 57 we have to find the magnitude of the total momentum of the two ball system after the collision. So collision before and collision after. So this is momentum problem. So momentum before is equal to momentum after. So I have two cars. So I have two ball. One ball is moving east, and this ball is 7.28, and moving east 8.50 meter per second, moving east. And another ball moving to the west, and this ball is 5.45 kilogram and moving to the west at 10 meter per second, and they collide. Once they collide, what is their momentum? After the collision, their momentum. So momentum before is equal to momentum after. So then we have to find the momentum after. So we're going to write momentum after is equal to momentum before. So momentum after is equal to m1 v1 plus m2 v2. So what is the m1? M1 is 7.28 kilogram, and v1 is 8.50 meter per second. What is m2? M2 is 5.45 kilogram, and what is the v2? V2 is 10 meter per second. No, it's not 10. It's to the west, so it must be negative. It must be negative. So 7.28. So 7.28 times 8.50, and that gives us 61.88 kilogram meter per second, plus minus 5.45 times 10, and that gives us 54.5 kilogram meter per second. And then now we're gonna do 68.88, and that gives us 14.38. So 14 point. So what is the final answer? Final answer is 68. 61. So 61.88 minus 54.5, it gives us 7.38. So 7.38 kilogram meter per second. So we are done. Okay, so then that takes us to the next one. Next one is 5859. So we're gonna do 5859 right here. We have lots of space. 5859, calculate the average power. So average power. The average power required to lift 490 Newton object. So we have 490 Newton object. Vertical distance 2 meter in 10 seconds. So distance is 2 meter and time is 10 seconds. So pretty simple. Now we're gonna take a look. We're gonna find the power, and that has those properties. So power, so FD over T. So we simply gonna use this one. So power is equal to, so FD over T. So F is 490 Newton, D is 2 meter, and T is 10 seconds. So that gives us, if you do them, that's pretty simple. That gives us 98 watts. 98 watts. That takes us to next one. The next one is 60, and 60 it says blah 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 blah. Okay, so that means these are the web, this is the hole, this is the opening, and this is the direction of the wave. So wave moves this way. So let's say this is the water wave. When water wave hits this opening, how that the shape look like after it passed through the opening. So after it passed through the opening, it looked like that, because this is just single slit. If you have a double slit, then there would be interference. There is no interference because just simple single slit. So that's how They ask us to draw 3, so we draw 3. 1, 2, 3. Now that takes us to the 61. So we know that in the transversal wave, they are calling mechanical transversal wave. Transversal wave, the medium oscillates at the direction, medium oscillates perpendicular at the direction, medium. It asks us to draw a diagram in the one it traveling the right in the okay. Draw a arrow to indicate the initial direction of the particle will move. So the particle moves. We know that particle. This is the particle. This is the particle. So why there is a particle? So the wave, everything made out of a particle. So this subatomic particle oscillate perpendicular to the direction of the wave. So this oscillate perpendicular to the direction of the wave. Then wave kind of carries the energy and information from one direction to, so wave, the energy moves this direction, and the particle moves the perpendicular, which is the perpendicular with respect to the direction of the energy. That's 62. That takes us to 62. 62 say regardless the method. Okay, 62 say input, why input is not equal to output. Okay, so if you have to electric energy to amount of energy provided by, so you want to create electric energy by using some other energy. So you know that energy can transform from one form to other form. Gravitational energy transform to mechanical energy, gravitational energy can transform to potential to gravitational, all kinds of things. So some other type of energy can transform to electric energy. So if I want to transfer 100 joule of some other type of energy, I may use this 100 joule to have the 100 joule of electric energy? No, because if I put this in the machine, some of the energy will be lost due to various things, energy need to overcome the friction. So some of the energy would be used up to overcome the friction. So then always output is always less than input. That's why the electric energy would be less than the some other energy that you use in order to get the electric energy, always, because some of the energy will be wasted to overcome the friction. That takes us to 63. Now 63 is easy and simple. Find the average velocity of the car from 6 to 10. From 6 to 10, we have to find the average velocity of the car. Now this is velocity versus time graph. How can we find the average velocity? Average velocity, we look at I told you a million times, velocity versus time graph. To find the velocity, look at the vertical line. What is the average velocity between 6 to 10? Not 0 to 10, just 6 to 10. Look at the average velocity. At 6 seconds, the velocity is 15. 7 second velocity is 15. 8 second velocity is 15. 9 second velocity, 10 second velocity is 15. Every single second between 6 to 10 is 15. So the answer must be 15 meters per second. Hopefully that makes sense. Determine find the car acceleration. So find the car acceleration now. So acceleration between from fast to 6 seconds, from 0 to 6 seconds now is different. So acceleration is delta B over delta t, which is V final minus T final, B final minus B initial, T final minus T initial. So V final is 15. So 15 minus B initial is 0. T final is 6 minus 0. So 15 divided by 0. Only God knows how much. I think 2.5. I don't have to use that. 2.5 meter per second squared. Very good. Now 60. That is the acceleration. That is 64. 64 is 2.5 meter per second squared. Now 65. Identify the physical quantity represented by shaded. So the shaded area. This is velocity versus time graph. If you have a shaded area, and the shaded area is distance or displacement. So always keep that in mind. Or the distance travel. So distance or displacement. So this is distance. or displacement. It doesn't matter. So, boom! Now we're gonna do 66. To draw an electric circuit, given this information, electric circuit has to be series and 12 volt. One lamp and one resistor. So let's do it. Plus minus. This is 12 volt, and this is our battery. This is lamp, and this is our lamp, and lamp is 10 ohms. This is our resistor. We do not know what is anything about a resistor, and the total current in the circuit is given 0.5 amps. We have to find equivalent resistance. Equivalent resistance is equivalence resistance is equivalence resistance is R equal to VIR. So the resistance is V over I. So V is, what is V? V is I don't know. V is 12 and I is 0.5. 12 divided by 0.5 is like 24. So 24 ohms. Okay, equivalent resistance is 24 ohms. Now the next one is find resistance of the resistor. Now we have to find the resistance of the resistor. So the total resistance is equal to resistance 1 plus resistance 2 by Ohm's law. So total resistance is 24 is equal to resistance 1. Resistance in the lamp is 10 ohms plus R2. So R2 must be 24 minus 10 is 14 ohms. So 14 ohms. So 64 is 14 ohms. 68. Fine. Okay, that's 68. Oh, okay, that's 68. 68 is 14 ohms, and 67 was 24 ohms. 24 ohms, 14 ohms. 69. Calculate the power. So we have to find the power. So we have lots of information. We have the resistance. Calculate the power. Calculate the power consumed by the lamp. So power in the lamp. So power is, if we look at the electricity, we're gonna see power. So this is our electricity. We have a power. So power is we are talking about lamp. This is the resistance, and the current is over here 0.5. Okay, so we're gonna use current and the resistance, not voltage. So we're gonna use current and resistance. So I square R. So I is 0.5 square, and resistance is 10. So 0.5 square is 0.25 times 10. So is I believe 0.25 times 10 is 2.5, and this is watt. 2.5 watts, and that takes us to the next one. The next one is 72, and that is like a planet. Pluto orbit around the sun. So Pluto orbit around the sun. This is mighty sun, and this is little Pluto. Pluto orbiting around the sun with average distance. So the distance between sun and Pluto is this much. Pluto diameter is this. Okay. And the Charon orbits Pluto, and then there is the other moon of the Pluto, and the Charon orbit around Pluto. Okay, blah blah blah. Find the FZ. So find the gravitational force between Pluto and Charon. The moon of the Pluto. So now we're gonna write G M Pluto. M Charon, which is the moon of Pluto, and over R squared. So Z is the gravitational constant 6.6 times 10 raised to negative 11. So G is the first number of the so 6.67 times 10 raised to negative 11. Now the mass of the Pluto is, I don't know. Mass of the Pluto is average distance and Pluto diameter, and its mass 1.31 times 10 raised to 22, and mass of the moon of the Pluto is mass 1.55 times 10 raised to 21, and the distance between these two guys is 1.96 times 10 raised to 7 whole square. If you do the math, you're gonna see 3.53 times 10 raised to 3.53 times 10 raised to, so so if you do the math, so 3.53 times 10 raised to 18 Newton. So that's what it gives you. Number 73 and 74. So 73 and 74, calculate the magnitude of the acceleration of okay, so now we're going to use the Newton's second law, F equal to ma. So acceleration is F over m. So F is this one, 3.53 times 10 raised to 18 Newton, and mass, so calculate the magnitude of the acceleration of Hadron. So the mass of the Hadron is 1.55 times 10 raised to 21, and that gives us I think 2.21 times 10 raised to 18 minus 21, that negative 3 meter per second square, and that takes us to 75. State the reason why the magnitude of sun gravitational force on photon is greater than the magnitude of the sun gravitational force, because whole lot of reason, because the mass of the sun is big, mass of sun, and the mass of the photon, mass of the proton is big, mass of the proton is big, and that takes us to the next one, and next one is 76, and that is oh, that is last page. Wow, what a surprise. So a horizontal force, 20 Newton force, is applied to 5 kilogram box to push it across the rough horizontal. We've seen this problem before. Okay, now find the magnitude of the force of friction acting on the box. Okay, so we have a box, there is a box, and 20 Newton force is applied to 5 kilograms. So this is 5 kilogram and 20 Newton. Fa is 20 Newton. Force, okay, and horizontal floor, and constant velocity, and velocity is constant, 3 meter per second. This is a big information, velocity. If velocity is constant, then what is the, so find the magnitude of the force of friction. So then force of friction must be 20 Newton. Force of friction must be 20 Newton. Why? Because the applied force and force of friction cancel out, so that's how the velocity remain constant. Number, find weight of the box. So weight of the box is Fg equal to ma. So F weight is equal to mg. So mass of the, so mass is 5 kilogram. 5 times I guess 9.8. So 5 times 9.8, 9.81 is, I believe, 49 Newton. And then that takes us to the next one. Calculate the coefficient of kinetic friction between the box and the floor. So kinetic friction, so we have to find the kinetic friction. So friction is mu times Fn. So the box is not moving down or moving up. We know that the gravitational pull on the box is, which is the weight, Fg is equal to 49 Newton. Then Fn must be 49 Newton, because the ball is not moving down or moving up. It is moving to the east with constant velocity, 3 meter per second. It does not move up or it does not move down. So then Fn must be equal to Fg. So or the normal force is must equal to the weight. So mu is equal to F friction over Fn. So we know that F friction is 20 Newton, and we know that the Fn is 49 Newton. So 20 divided by 49, I don't know, maybe 41, maybe 0.41, I don't know, we just double check. So mu has no units, so mu is 0.49. And then that takes us to the last problem, 81 to 85. So 81 to 85, an electron moves this much meter per second collide with a photon having frequency this. After collision, the photon okay, so calculate the original kinetic energy of the electron. So kinetic energy of the electron is kinetic energy. We know that kinetic energy is equal to half mv squared. So half the kinetic energy of electron, so mass of the electron is, I believe, 9.11 times 10 raised to negative 31. How do we know? But just to make sure, double check. 9.11. So 9.1 and 10 raised to negative 31. See over here, the b v is given, so 2.5 times 10 raised to 6. So if you do that, this is a very simple math. You get 2.85 times 10 raised to negative 18 joule. Now next number, find the energy of the joule of the photon before the collision. So before the collision, what was the energy? So before the collision, energy is equal to hf. So before the collision, energy is h is 6.6 times 10 raised to negative 34 times frequency. Frequency is given, so frequency is 1 times 10 raised to 16 hertz. So if you multiply that, this is simple, just put it in your calculator, then you're gonna see energy in joule before. Oh, we are trying to find energy in joule before, yeah. So 6.3 times 10 raised to negative 18 joule. Now 83, so we just did 83. Now 84, find the energy loss by the photon. Find the energy loss. Energy loss is equal to, what is energy loss? So the energy, so after the collision, this is the energy, and before the collision, so energy before minus energy after gives us the energy lost. So energy before is 6.63 times 10 raised to negative 18, and energy after the collision 3.18 times 10 raised to negative 18. So 6.63 minus 3. So 6.63 minus 3.18 gives you 3.45. So 3.45 times 10 raised to negative 18 joule. So energy lost, so the energy lost is this much. Now physical quantities conserve so what type of physical quantity conserve in the collision? So when two things collide, what type of physical quantity conserve? Mass conserve, and what charge conserve? Charge concept, mass concept, charge concept, lots of other thing concept. Okay, now we are we did 2016 and then 2015, and we just done 2014, and now I wish you good luck. I'll see you. Make sure you watch all those videos, and I'll randomly choose one of the quiz, either 2016 or 2015 or 2014. Just watch all of them. Then if I give you randomly choose one of them, and if I randomly choose 2016, and you take 2016, and if you watch the video, you should be able to finish it in 10 minutes, and then you should be able to get 100. Imagine you get 100 in the last quiz. That gives you, that boosts your your confidence. That boosts your confidence. If you with 100 points in your last quiz, then you will be, oh, let me take the results, and you get 100 in the results. Good luck, guys. Bye bye.